This video module will introduce the flight control surfaces and associated components on the tail section of the Boeing 767. It will describe their function and operation, as well as show access and location of the major components. The flight control surfaces include the horizontal stabilizer, elevators, and rudder. The flight controls are powered by pressure from the hydraulic systems. In the event of a dual-engine failure, the ram air turbine, or RAT, is deployed. This provides the necessary power to the primary flight controls to maintain control of the airplane. New lightweight materials are used extensively in the manufacture of the 767 flight control surfaces and associated hardware. Graphite epoxy materials have been incorporated into the flight control surfaces. Titanium, fiberglass, and advanced aluminum alloys are used in the supporting structures. Each of the control surfaces will be shown, beginning with the horizontal stabilizer. A movable, single-span horizontal stabilizer extends through the aft section of the fuselage and provides a means of trim in the pitch axis. The horizontal stabilizer is controlled by manually operated electric trim switches on each control wheel and manually operated levers on the left side of the control stand. Automatic operation of the stabilizer trim system is controlled by the autopilot control system. Hydraulic cutout switches are located on the center control stand. Manual trim levers override all other input command signals. These are primarily intended to be used only in an emergency. An emergency cutoff circuit is operated by the control column to arrest runaway pitch trim. When the pilot moves the column in a direction opposing trim, electric power to the automatic trim system is interrupted. Stabilizer trim indication components in the flight compartment include amber fault lights for stabilizer trim and unscheduled stabilizer trim, horizontal stabilizer position indicators, and engine indication and crew alerting or ICAS displays. Located in the main equipment center are the horizontal stabilizer electronic components. They include the stabilizer trim and aileron lockout modules, left and right, and the flight control computers. Located forward of the equipment racks and accessed through the right crawlway is the flap and stabilizer position module. Horizontal stabilizer components in the stabilizer compartment are accessed through the lower service access door. These components include the stabilizer center section, ball screw actuator assembly, hydraulic motors, left and right, and hydraulically released brakes, left and right. Mounted on the floor below the stabilizer center section are 3 position transmitter modules. Just aft and above the ball screw actuator are the stabilizer trim control modules. The elevators are connected to the trailing edge of the horizontal stabilizer. They provide attitude control of the airplane about the pitch axis. The elevators are controlled by pilot input commands on the control columns or by the autopilot control system. Elevator system indications appear on the ICAS display. Accessed through the hatch forward of the nose wheel well are tension regulators and force transducers for the captain's and first officer's control columns. Mounted on the elevator torque tube are two stick shakers. Located in the stabilizer compartment on the forward bulkhead is the field computer. Located in the controls bay, just aft of the center section of the horizontal stabilizer, are two aft quadrants, field unit, field actuator, neutral shift linkage, and autopilot servos. Each elevator is controlled by three power control actuators. These are accessed by removing the panels on the lower side of the horizontal stabilizer. Near the inboard end of the inboard elevator are the elevator position transmitters. The last of the control surfaces on the tail section of the airplane is the rudder. The rudder is located on the trailing edge of the vertical stabilizer and provides continuous directional control of the airplane about the yaw axis. The rudder is controlled by pilot input commands on the rudder pedals. It is also controlled by the autopilot control system during landing. The rudder trim knob and trim indicator are located on the aft pilot's control stand. Positioned on the left side of the P61 panel are the flight control shutoff valve switches and indicator lights. The amber rudder ratio light is located on the P5 overhead panel. Rudder pedal adjustment cranks are forward of the captain's and first officer's seats. Located below the flight compartment in the forward equipment center are the captain's and first officer's forward rudder quadrants and rudder pedal steering mechanism. These are accessed by the crawlways through the main equipment center. Located in the main equipment center are the rudder system electronics components. These include the stabilizer trim and aileron lockout modules, left and right, the rudder ratio changer modules, left and right, and the yaw damper modules, left and right. Located in the stabilizer compartment just forward of the horizontal stabilizer are elevator and rudder shutoff valves. These are accessible through the lower service access door. Additional rudder system components are found within the vertical fin. Access to these components is through panels on the left side of the fin. These components include three directional autopilot servos for rudder control during landing. Located above the autopilot servos are the aft quadrant, field centering and trim mechanism, rudder trim actuator, rudder ratio changer actuator, rudder ratio changer mechanism, load limiter, two yaw damper servos, centering and bias spring, rudder position transmitter, and three power control actuators which are powered by independent hydraulic sources. This video module has introduced the flight control surfaces and associated components on the tail section of the Boeing 767. It has described their function and operation, as well as shown access to and location of the major components.